Welcome. We will continue learning how to use MATLAB as a calculator. So we will apply these topics that we learned in part 1 and part 2 to solve an engineering problem. So let's start. So we have this problem. A canal was constructing running parallel to a river. So you have a canal here and you have like a river here, and they are 2,000 meters away. Both fully penetrate a sandy aquifer. So here is a sandy aquifer where like groundwater is flowing, and it has a hydraulic conductivity, this aquifer, of 1.5 meter per day. The area is subject to recharge of 0.0017 meter per day. So you have like some recharge component here that's recharging like the aquifer. The elevation of the water in the river, H1 here is 30 and H2 here in the canal is 20. The width into the river and the canal is 60, so the width inside the screen is 30, and it's telling you number 1, determines the water divide. So the water divide, that would be like somewhere here. That's like an boundary, like an imaginary boundary, which is like a no-flow boundary. So here at a water divide, like, so the water will infiltrate from here and recharge the aquifer. Water to the left of this divide here, it will flow to the river, and water to the right will flow to the canal. That's like a groundwater divide. So basically there's no flow component across this divide, like no flow from here to here or from here to here, easy, but just like this and like this. Okay, and then it asks you like a maximum water table elevation. So at this water table divide, that's where you have this maximum water table elevation. And then discharge into the river, like whatever is discharging here, and like daily discharge into the canal, whatever is like this Q is discharging here. Okay, and for each one, like, you have the equation, and then it tells you display your answer in 2 significant figure with annotation using display function. So you remember we did like the display function here, and we also, that was in video part 1, and we did some discrete mass function like rounding in, that was in part 2. So now we will apply what we learned in these 2 videos to solve that problem. Okay, let's start. So that's like like how to start, like you put like your input first. So what's my input? So L is equal to 2,000. Remember, like this $ input means like a command, so that's something that's not executed. K is equal to 1.5. Omega, which we will call it like W, is equal to 0.0017. H1. Here, I mean, I could also remember, like, I could use H1, like, that's underscore is permissible in naming a variable name. So I could use underscore to improve readability, so that this like will know that this is an underscore, like I put this underscore sign, like this is a subscript, but I can just leave it. It's easier just to write H1. Okay, so that'd be 30, and H2, that would be like 20, and like the width, let's call it like big W, capital W, like 60. Okay, and then we start with the first one. So the first one, like, let's do this so that we know what we are doing. Put like this comment sign here. So number 1, which is water divide like D, and what do I have for D? Like, and this, see, very simple, much simpler than Excel. Like Excel, you have to go select something. Here you just type what you see on the screen. So here L over 2 minus K W time H1 square minus H2 square divided by, and then should I just write divided by 2 times L. This is correct? No, this is according to the precedence rule. We learned it before. If I divide it by 2 and multiply by n, then it will like divide this whole term by 2, then multiply by L. But this is not what I want. I want to divide by 2 times L. So there must be like a bracket here. Okay? Let me clear all the outputs, and then let's run this one and see what we are getting. So I got my D is equal to something like this. Now it's telling me round it to two significant figure. I mean, we can do it now, or we can do it at the end. Let's just do it now. Okay, so like you say, like round D, and then so two significant figure means that like I need to get rid of all these guys and get rid of this guy. So that should be like 890. So how to do this? Then I think, like, remember, if I want to round to the nearest integer here, then this round function will take a 0. If I want to get rid of this guy, then it should get like a -1. So let's try like -1, round the -1, and then I got like what I want. Okay, now let's do part 2, the maximum, this one. So put a comment here, and then the maximum water table equation H max. Okay, and then I will say like H max, that's equal to square root, remember to use the square root function, H1 square minus, we open parentheses, H1 square minus H2 square, close parentheses, time D divided by L plus W over K. Oops, I do some W plus something is, I think MATLAB is doing some auto completion here. W over K, oops, K time L minus D time D. Okay, so then I run this and I got something like 42, and again I need two significant figure, which means I need to get rid of these guys. So here I could say like H max is equal to round H max, and here I just round to 0, or I just can leave it round. I will just write round to 0. So now I got like 52, like two significant figure. Here I have like 890, two significant figure, because this 0 is a non-significant figure. It's not a significant figure. Okay, then number 3 and 4. Let's do this one, daily discharge. So here like the daily discharge. See, I copied this, I copied as a text, not as a code, but that's okay. We can, oops. Maybe comment them like this. Need to drag them here. Oh, not working? Okay, let's do this. Just a little bit. Okay, now. Sometimes dragging will not be as successful as you want it to be. Okay, so here number 3 and 4 is tell you discharge into the river. So basically discharge into the river, I have like this equation, which is a function of x. So the river here, the discharge is the river, so x here is 0, x here is L. So at the river, x is equal to 0, at the canal, x is equal to, like x all the way here is equal to L. So now let's do the first one. So here I will say x is equal to 0. That's like discharge at like the river. Then I enter my equation, which is like qx. Let me make subscript like river, so I know that this is for the river. And then I open parentheses, because I have this big parentheses there, k time h1 square minus h2 square divided by, don't forget the parentheses, 2L minus omega, like W here, divided by L over 2 minus X. Do I need a parentheses here for L over 2? If you are in doubt, just put a parentheses. But here I don't need a parentheses, because why? Because like the division has precedence over the subtraction. So the computer will come here, it will first do this division, then do subtraction. So I don't need a parentheses, but if you are in doubt, doesn't hurt to put like a parentheses. Okay, then I will make here times W, and that would be like let's run this one. So I got something like this. Why am I getting a negative sign? Because the discharge here, like here, this is my positive X. The discharge is in the counter direction of what I defined as positive. So basically the negative sign means that the discharge in this direction, not in this direction of X. That's why I'm getting the negative sign. Now it's telling me to do some rounding, so I can say like H X R, that would be round. Oops, I made a mistake. That's not H, that's Q. X R, and mistake here. That would be like round. Q X R, and again, I need two significant figures, so I need to get rid of like. So like that's like 0, remember, that's like -1. So I go here like -1. And then if I did this, hopefully I got like, yes, two significant figures, 9 and 1. Okay. Now we do it for the other one. We do the same thing here. Let me just comment this one for now. X here will be equal to L, and that will be QR the canal. Okay. And then if we run this, then I get like 1.123 to the power of 3. So I need to do this like in two significant figure, which would mean here like maybe let me show you, for example, with -1 first, then I will show this to you with like so if I okay, see here I did a mistake, because I didn't change this. Like this should be like round C and round C. So I got the same number. So here I did because -1, so that's like my number. With -1 I get like 3 significant figures, so maybe like do -2, then I got it like in 2 significant figures. Okay. Now that's not it. We still have one more to do, which is display. Like use the display function to describe whatever you are doing. Okay. So that like the reader will have like a better output. So I can say here display, and then I could write the water table divide is here. Like remember, if that's a string. If I want to use this, then I have to, that's a number, I have to convert it to string. So like number to string, and that would be like D, and then plus I put here like meter from the river, something like this. And then we go here and we do the same, like this display, and then the maximum water, maximum water table elevation is, and then plus number to string, and then H max, and that is plus, that's something like in meter, something like this. And then I can do it for like the rest of them. Let me just copy and paste them from here. So for this one, and for this one is just like the same, like you just type whatever annotation you need to give to the user. So now I can suppress all these outputs. Like I can suppress like this one, suppress this one, suppress this one, suppress this one, suppress this one. You use the semicolon to suppress the output, and then I will just display this to the screen. Oops, I have something here that's still not suppressed. And display, oops, this is here like the river. Should like make sure that you have like the correct variable name, otherwise it will unrecognized function, because QX river, that's like not defined here. So like what I defined here is QR. So then I got my output, like the maximum water table divide is 890 meter from the river. The maximum water table elevation is 42 meter. Discharge into the river and discharge into the canal. I could also maybe annotate my solution, right? What is L? Like annotate it. So you see here, this is the solution. That's like, if you want to make your code more readable so that the user will just look at it and understand. So here, like L, that's distance from the river to the canal. K is hydraulic conductivity. This is recharge, water table elevation to the river, water table elevation to the canal. That's also in meter. Depth of the water to the canal, that's also in meter. And then you run your code. So if we run this code, we should get like the same answer we got above here. Okay, so now we've seen, we've learned how to use MATLAB workspace, what is a scalar and array variables, how to do some arithmetic operations with MATLAB, both like as like a matrix form, like as a linear algebra, and as like simple arithmetics. And we learned some elementary function, common mass function, trigonometric function, discrete function, like for like rounding, and descriptive statistic function, and some constant. We learned about the precedence rule, and we applied this to an engineering problem. So now you can use MATLAB as a very sophisticated calculator, much easier than your calculator. And let me show you why this is much easier than like using a calculator. Because now if I asked you, what if the recharge increased? So I have like here, I have here like recharge is 1.27. What if I have more recharge? So if I have more recharge, what will happen? So if you are doing this with the calculator, you have to repeat all these steps. With MATLAB, you just change the number. So I increase recharge, and then if I increase recharge, my maximum water table elevation is now like, instead of 42, now it's 49. So that's like your water table here. The water table, that's like the top of your unconfined aquifer, and the pore water pressure would have would be equal to the atmospheric pressure. That's the definition of the water table. So I will have like the water table will, if I have more recharge, it will go up here maybe, and then maybe I will start to have flooding situation, like water will not infiltrate, and then I could get a flood or something like that. So that if I increase like this recharge, or that's happening here. What if there's no recharge, like nothing is infiltrating from here, it's just like water is flowing from here to here. So if there is no recharge, that's an interesting situation. Like if I want to test, what if there is no recharge? What will happen? So if there is no recharge, the water table divides us minus infinity. And that's exactly what we expect. If there is no recharge, this water table divide will not exist, and just water will flow from H1, like high energy, to H2, to low energy. That's water will be just flowing from here to here. That versus if you have this water table divide, water is flowing like from top to here and from top to here. But no recharge, water flowing from left to right. So basically what we got is that like we have this term here, W, so that would be your water table divide K divided by W. So K divided by W, that's like you should be like undefined, not a number, but MATLAB here, I don't know, do it like as a negative infinity. I have to check into this. So here, like, you have like an infinity and minus infinity plus anything that will still be minus infinity. So I got this minus infinity here. And then here I got, this is 0. So I got like the H max will be the maximum water table elevation. That should be yeah, because that's like minus infinity. So I take like minus infinity and then I put it in like this bracket, and I got like takes the square root of it, then it's like not a number. So that's what I expect. And then like if we look at Q, daily discharge into like the river, like we here get a different number because here like it's only like using one significant figure, because now I need to change this to -1. Or maybe let's just show the actual value without any rounding. That'd be easier. So okay, let me just comment this to just show the actual value without any rounding. So if I commented this, then I will display like this value without rounding. So I comment this. QXML. So I run this. So I got like the same discharge, and basically, and with the same sign, basically it's telling me this charge here is equal to this charge here, like whatever my Q here is equal to my Q here. Whatever is entering the system is leaving the system. Like my input here is equal to my output, because there is no change in storage. Okay? Versus in that case, there was a change. There was like a change in storage. Like whatever was entering here, part of it went here to raise the water table, and part of it went here, and part of it went here. So there was like a change in storage. So that's like our engineering problem. So you can test all these cases simply by just a change. Like what if the head here changed? What if the width changed? What if I have less hydraulic conductivity? What if I have more hydraulic conductivity? So that you can play, this is like a little toy that you can play with to understand like the physics and like understand like what's happening here. Okay, so that's all for this lesson, and see you in next lesson. Bye bye.